A single cylinder engine of total mass 200 kg is to be mounted on an elastic support which permits, so this is your M1 entire mass, which permits vibratory movement in vertical direction only. The mass of the piston is 3.5 kg. This is your disturbing mass, m omega square r mass. Okay, has a vertical reciprocating motion which may be assumed to be simple harmonic with a stroke of 150. Half of this is your m omega square r radius. It is desired that the maximum vibratory force transmitted through the elastic support to the foundation shall be 600 Newton, not exceeding 600 Newton. So Ft is 600. Okay, when the engine speed is at 800 rpm and less than this at all higher speeds. To find the necessary stiffness of the elastic support and the amplitude of vibration at 800 rpm. If the engine speed is reduced below 800 rpm, at what speed will the force transmitted again become 600 Newton? Two questions are there. Okay, so given data, so entire mass, the whole mass for finding stiffness and deflection 200 kg, disturbing mass is 3.5 kg. So stroke length is 150 mm, half of that is your radius which is 0.075. So Ft is 600 Newton directly given. So 800 rpm speed we are going to take, omega of that is 83.8. Okay, you know that disturbing force at 800 rpm, F equal to centrifugal force m omega square r. So 3.5 kg piston is taken as the disturbing mass. Okay, so omega is 800 rpm, 83.8 radius per second. Radius is half of the stroke length, 150 mm is 75 millimeter. Multiply that, we get 1843 Newton is the centrifugal force, disturbing force created. Stiffness of elastic support and amplitude of vibration. Let S equal to stiffness and X max equal to maximum amplitude. Since the maximum vibratory force transmitted to the foundation is equal to the force on the elastic support neglecting damping, therefore maximum vibratory force transmitted to the foundation, that is force on the elastic support, equal to stiffness into amplitude. Very simple, straight away you can write stiffness into amplitude. Ft equal to stiffness of the springs put together multiplied by the amplitude of the vibratory motion. So stiffness is S into X max. This S into X max is only for the cases where there is no damping. Otherwise you cannot write this. Okay. So Ft equal to S into the formula for X max from the last derivation, we can see F by m into omega square minus omega n square. So Ft equal to S into F by m into omega square minus omega n square. So in place of omega n square, I am putting root of S by m square. Okay. So omega n equal to root of S by m, omega n square is S by m. So Ft equal to so I'm taking LCM and cancelling out the m. So if you take LCM of m here inside the bracket, what will happen? M omega square minus S by m, this m and m get cancelled, you will get a m here. So m omega square minus S, that's what I have done. So 600 should be the force transmitted, not exceeding 600. So keep it as 600. Yeah, keep only the stiffness value as unknown. Calculate the stiffness. Cross multiply. Do mathematical manipulation. Stiffness comes around 344 into 10 power 3 Newton per meter. Any doubts in this? Okay. So only new thing I have used here is this X max. How did it come? X max is force by m into omega square minus omega n square. Okay. Amplitude. So stiffness of the elastic support equal to 344 into 10 power 3 Newton per meter. So maximum amplitude of vibration, F by m omega is the same thing you have simplified as F by m omega square minus S. So I know all the values now. Put it. Since you also know the stiffness, you calculate the stiffness value. 1.745 into 10 power minus 3 is the maximum amplitude. Okay. So maximum amplitude of vibration is 1.745 millimeter when your Ft is 600. Okay. So speed at which the transmitted force again becomes 600 Newton. Transmitted force will rise as the speed of the engine falls and passes through the resonance. Okay, there will be a speed below the resonance at which the transmitted force will again become equal to 600. Let the speed be equal to omega 1. This omega 1 is a suffix. It should come omega 1 below. Okay. So disturbing force m equal to m2 omega 1 square r. Keep this omega 1 as unknown. So that's what I am going to find out. I know the F value 600. At another speed at which your 600 becomes a force 600, that's what I am trying to find out. So 3.5 into omega 1 square into 0.075. So that is 0.2625 omega 1 square. Okay, since the engine speed is reduced below N1 800 rpm, therefore in this case maximum amplitude of vibration equal to F by omega n square minus omega 1 square. Okay, what was it previously? Omega square. So here, see here, it was a higher speed, therefore omega n is behind. Now I am bringing the speed below the natural frequency. Only then again at another speed I will get the same force. So therefore this goes to the front and this comes to the back. Omega. I am keeping omega, second omega is omega 1. Okay. So omega n square minus omega 1 square. So that is in place of omega n I am putting s by m in simplifying solving. So what becomes s minus m into omega 1 square. So I am cancelling that m in the denominator out with the m outside the bracket. So you take LCM and cancel this m out. So you will get 1 m here, m into omega 1 square. S minus m into omega 1 square. Okay. Force transmitted S into x max. So F by S minus m into omega 1 square. So what is unknown here? Omega 1 is unknown. Stiffness value is known. So F is equal to stiffness, Ft is 600 Newton. Put all the numbers and find out, solve for omega 1. Okay. So rearrange, multiply, cross multiply, manipulate everything, you will get omega 1 is equal to 31.32 radians per second. Convert that into RPM. It is 299 RPM. It is very low speed. So at 299 RPM again, initially at 800 RPM I had 600 Newton force exerted. Again at 299 RPM I am getting 600 Newton force exerted. Speed at which the transmitted force again becomes 600 Newton is 299 RPM. So that is the significance of your natural frequency. If you avoid the natural frequency and operate well below or well above, you will not have resonance. It is not that you should not exceed natural frequency. You can go higher frequency also. Nothing bad will happen with that. So this is taken from your Kurmi textbook 23.24 problem. So that completes